Yes,
Yes,
okay.
yes, yes. So please,
Shall
sir.
we start?
Dr. Sir. Yes,
Okay.
yes.
Okay. Respected ATAL coordinators, distinguished resource person, respected colleagues, and dear participants from various institutes across the country. Good evening to one and all. On behalf of Zeal College of Engineering and Research and Department of Mechanical Engineering, I warmly welcome you all for the day 4 of ATAL Online 6-day Faculty Development Program on Artificial Intelligence and Machine Learning in Mechanical Systems. Now, it is my great pleasure and honor to introduce today's distinguished resource person, Dr. Mehdi Mehtab Mirat. So, Dr. Mehtab Mirat earned his B.Tech degree in Mechanical Engineering from Todi Ram Reddy Institute of Technology and Science, Hyderabad in 2016. Then M.Tech in Mechanical System Design and Innovation Technology from NIT Arunachal Pradesh in year 2018 and PhD in Manufacturing from NIT Silchar in the year 2024. Dr. Mehdi has worked as assistant professor in the Department of Mechanical Engineering at NIT Karnataka, Surat from July 23 to December 2023. He also worked as assistant professor in Department of Mechanical Engineering in Chennai Institute of Technology, Chennai from November 24 to June 25. Currently, he is working as postdoctoral fellow at University Technology, Malaysia. Dr. Mehdi has published more than 20 research articles in reputed international journals, conference proceedings, and book chapters. His main research interests includes advanced machining processes, additive manufacturing, numerical modeling, and condition monitoring. So, with these words, I once again warmly welcome Dr. Mehdi Mehta Mirat and now invite him to kindly take over the session. So, thank you, Dr. Mehdi. Over to you, sir.
Thank you so much, sir. Good evening to all. I'd like to thanks to the organizers for giving me this opportunity to gather my thoughts on this topic, signal-based data-driven condition monitoring in ultrasonic machining of Inconel 718. It's pleasure to hear with the participants and interact with them on this topic. Outlines of presentations are introduction, literature review, research gaps, then research objectives, then materials and methodology, then results and discussion, then conclusions, then feature scopes and limitations, then list of publications, then references. Now coming to the introduction. First of all, comparing with the conventional machining process and non-conventional machining process. Conventional machining process refers to material removal process that use a sharp cutting tool in direct contact with the workpiece. The tool applies mechanical energy, that is force plus motion, to shear off material in the form of chips. It generally requires harder tool material than the workpiece, widely used for metals, plastics, and softer materials. Limited for hard, brittle, and composite materials. Examples of conventional machining process are as turning, milling, drilling, grinding, and so on. Non-conventional machining refers to process that remove material from a workpiece with high precision and efficiency, and there is no direct contact between tool and workpiece. These processes were developed to overcome the limitations of conventional machining processes in dealing with hard, brittle, or complex materials and in achieving high precision. Non-conventional machining processes are as USM, UDM, OEDM, ECM, EBM, and so on. Now, coming to the ultrasonic machining process. Ultrasonic machining is a non-conventional machining process which is used to machine hard and brittle material. Non-conventional machining is defined as the process in which materials are removed from the workpiece in most accurate and effective way, and there is no direct contact between tool and workpiece. And this machining process first came into existence in 1950 for finishing EDM surface, and day by day it is easable like to machine the materials such as ceramics, carbides, glass, precious stones, hardened steels, and so on. Now coming back to the principle of machining process. First of all, low electric energy passes into the transducer, and through this transducer, low electric energy converted into mechanical high frequency mechanical vibration, and this high frequency mechanical vibration passes through the booster, and through this booster this high frequency mechanical vibration is amplified, and this amplified high frequency vibration supplied to the horn, and through this horn this high frequency vibration passes through the tool, and due to this high frequency of tool high frequency of vibration, then tool gets vibrate, and here the workpiece is there, and in between tool and workpiece there is abrasive particles. Here abrasive particles can be considered like aluminum oxide, boron carbide, diamond dust, and so on. This is the magnified view of this um, cutting mechanism. Now, applications, advantages, and disadvantages of ultrasonic machining process. In applications, it is used to machine hardened brittle material like carbide, ceramic, glass, etc. It is used to manufacture silicon nitride turbine blade, diamond cutting. The dentist used ultrasonic machine to drilling of false teeth without creating pain. It is used to drill holes in wire-drawing dies. In advantages, it provides high accuracy and surface finish. It's hard and brittle material can be machined easily. Non-conductive material also can be machined using ultrasonic machining process, and there is no heat generation in workpiece during machining process. There is no direct contact between tool and workpiece. Though it's having so applications and many advantages, it's having some disadvantages like material removal rate is low, tool wear rate is high due to use of abrasive particles. Setup cost is high, it's higher consumption, selection of tool material is difficult. Now, condition monitoring. What is condition monitoring? Condition monitoring for health prediction and quality control is a major component of predictive maintenance, is to avoid substantial damages and its consequences. Main parts of condition monitoring systems are three. These are data acquisition, signal processing, and feature extraction. System consists of sensors, a computer with programmable software, and data acquisition measurement hardware. This process begins with sensors to measure the electrical or physical quantity such as pressure, temperature, or sound in the presence of a computer. The electrical signals from the are fed and it converts the analog signals into digital output values which can be influenced through a computer. Signal processing, this process in which the characteristics such as frequency, amplitude can get sensed is called the signal processing. Feature extraction refers to the process transforming raw data into numerical features that can be processed while preserving the information in the original data. It describes the techniques of functions of the variables to get a large set of data with sufficient accuracy. Now, signal processing techniques. One is Fourier transform, and another is Oblate transform. In Fourier transform is an operation that transforms data from the time domain into the frequency. It is used in linear time inference systems, filtering, diffraction, interference. Wavelet transform is used for performing signal analysis when signal frequency varies over time. It is used in image processing, human vision, radar, earthquake prediction sector. Main difference of Fourier transform and Wavelet transform is Fourier transform, this signal is like converted into frequency domain, and Wavelet transform, the signal is converted into time and frequency domain. Like Fourier transform is only frequency domain, and Wavelet transform it is available in time as well as frequency domain. Machine learning is a subset of artificial intelligence. Based on the predefined data, it predicts the new data. Support vector regression. A support vector machine is a discriminative classifier formally defined by a separating hyperplane. In two-dimensional space, this hyperplane is a line dividing a plane in two parts, where in each class lay in either side. This is the example. A sample cut to divide into two classes. Then support vector regression. Support vector regression performs linear regression in a higher dimensional space. It is used to minimize the error and individualize in the hyperplane, which maximizes the margin. Then I have gone through the so many literature reviews. Here few are like represented, and from this literature review is found that few research gaps are observed, like possibility to study the effect of different process parameters in ultrasonic machining, application of machine vision system in ultrasonic machining. There are limited work has been carried out based on condition monitoring system, sensor vision and sensor vision in ultrasonic machining for system health prediction. No work has been carried out with Incolon 708 superlight in this research domain. Based on few objectives were finalized to investigate the effect of process parameters on the machining performance in ultrasonic machining, to design and develop an automated system for system health prediction in ultrasonic machining using artificial intelligence system, to design and develop a sensor integration and sensor fusions modeling for tool health monitoring. This is the flowchart of the experimental procedure of machining process. First of all, materials are selected, and those materials were like analyzed through EDX process. Then parameters are selected, and based on the parameters, design of experiment is made. And then tool preparation was done, and then setup preparation was done. Then sensor was selected. In sensors, AE and current sensor means acoustic emission and current sensors are considered. After that, experimentation was carried out. After experimentation means one way means NANOBA analysis was done for the optimization process, how the input parameters are affected towards like output response parameters. And this is during machining process, like signals are acquired using the uh, sensors with the help of data acquisition system, and then these signals are processed through some signal processing techniques for the extracted features. And with these extracted features, then support like machine learning model was developed, like SVM, and like SVR support vector regression model was developed with these extracted features. And based on the model, and discussion was done. Then based on the results and discussion, conclusions was made. During experimentation, the raw materials are considered as workpiece material is Incolon 708. Like I working principle of ultrasonic process is the ultrasonic machine is used in only hard and brittle materials. But in Incolon 718 is not like a hard or brittle material, it's ductile material. My ambition was to like examine whether the any other materials also can be machined by ultrasonic machining process. This tool material is considered as tungsten carbide, abrasive material boron carbide, boron carbide is considered, this is the hard particles as abrasive material. Most hard particles is diamond dust, but diamond dust is more costly. So boron carbide is considered during this process, and slightly there is water. It can be oil also. Now, the mechanical properties of workpiece material in consumer unit. Ultimate tensile strength of consumer unit is 997 megapascal. Yield strength 766 megapascal. Young's modulus 204.9 megapascal. Critical hardness 363. Thermal conductivity 11.4 watt per meter into Kelvin. Pulse ratio 0.29. And this is the same image, and this is the EDX plot. This chemical composition of consumer unit. This is the physical properties of consumer unit. Density is 8.2 gram per centimeter cube and melting point 1571 Kelvin. And this the tool material tungsten carbide. This image. This is EDX plot. These are the mechanical properties, and this is the chemical composition of tungsten carbide, and this physical properties tungsten carbide. And this is the abrasive particles boron carbide, and boron carbide was considered as three different grain size or mesh size. These are like 220, 400, and 600. This is the same image of 220 mesh number, and this is 400, and this is 600 mesh number, and this is EDX plot for 220, 400, and this is 600. This is chemical composition for 220 mesh number, this is 400, and this is for 600 mesh number. And here, selection of process parameters, like in ultrasonic machining process, several input parameters are there, and as well as like several output parameters are there. So from these numbers of input parameters, I have considered abrasive pieces like concentration and power rating to observe the output resistance parameter as tool wear, all versus, and surface roughness or surface finish. This selection of parameters with these levels, the abrasive pieces, which is mesh number 220, 600, slide concentration 20%, 30%, 40%, power rating 40%, 50%, 60%. This is a general experiment. This ultrasonic tool is prepared with this dimension. Working diameter is 1.5, and driving diameter is mm. With this length is 20 mm. This is the workpiece sample. The selection of sensors. AE sensor with this specification, its type is acoustic measurement. It's made by GRAS sound and vibration. Model is GRAS 46 AE. Its accessories: one channel CCP per module with a weighting filter. Current sensor is a Hall effect current sensor made by W Instec. Its model GCP 300. Its range is 10 millivolt per ampere to 100 millivolt per ampere. Data acquisition system. It's a voltage measurement type. It's made by National Instruments. Its model NI USB 6259. Its range is 0.1 voltage to plus minus 0.1 voltage to plus minus 10 volt. It's 16-bit processor. Its maximum sampling frequency is 1.2 megahertz. Its number of input channels are 16. This is the experimental setup. Here, A is transducer, B is horn, C is tool, D is workpiece. Here is a slurry delivery system. F power unit. This is G control unit. This control unit. H this is AE sensor. Here is the sensor is used, and this current sensor. There is current sensor, and this is navigation system. This is personal computer. Here is the two main focus about this part. This is personal computer. This is data acquisition system, and this is current sensor, and this is AE sensor. Just I want to show the recorded video during this experimentation. Like during this experimentation, during machining, some sounds are generated, and these sounds are absorbed by this sensor, and these sounds are detected by this sensor, and through these sounds only means whatever the noises, for removing this noise, filter is used. That filter is bandpass filter. And time is set for 2 minutes for each experiment. Finally, this machine part is there. Here, actually, this is a programmable computer. Yes, this algorithm is there, and this is system. Here, with this means where current and equation sensor are connected with this data system as a analog input. This system to computer is connected as analog output. Now, tool weight measurement. An electric weighing device, precision analytical balance with a precision of 0.0002 gram is used for the measurement of tool weight. And using this equation, tool wear in weight percentage equal to tool wear before machining minus tool wear after machining by tool wear before machining into 100%. Then hole overseas measurement. Here, hole overseas indicated the difference between hole diameter and tool diameter. And to examine the machining hole diameter, the image of all machining holes are taken by a high resolution metallurgical optical microscope. This microscope is used to capture this machined hole. And to consider this hole overseas is used. Hole overseas equal to average hole diameter minus tool diameter. Like tool diameter and average hole diameter. Like here, few dimensions are considered, and with these few dimensions means average diameter is considered, and then this average hole diameter minus tool diameter is considered to consider hole of. This is during this machining process, these signals are acquired. This is AE signal means equation signals, acoustic signal, like without using filter. and this is after using the filter. Then filter is Bentwas filter is used, and this is in time domain. This is the before filtering, and this is after filtering, and this is some other experimental conditions. These are the after filtering process. This is the current signal. This is like a raw current signal before filtering, and this is after filtering. These are the some other experimental conditions. Like with these like signals, like in A sensor, like A signals and current signals. These current signals are not suitable for the uh, like if like current signals are not found suitable, and hence it considered for further study, and A signals are like found suitable, so A signals are considered for further data processing processes. And through these AE signals, then these A signals transfer to the discrete orbit like discrete orbit transform. This A signal is available only in time domain, and this discrete orbit transform is available in time as well as frequency domain. This discrete oblate transform is any oblate transform for which the oblates are discretely sampled. Here, this discrete oblate transform, these discrete oblates are decomposed in two steps. One is details coefficient, another is approximation coefficient. Here, coefficients are having high frequency and noises. Hence, these details coefficients are not considered, and approximation coefficients are fine, accuracy, hence considered. These WC's Fourier transform are one of the most common form for this discrete Fourier transform. Here, this WC's 10 oblate WC's 10 mother oblate function is considered during this uh, analyzing process. This is the other experimental conditions. This is experiment number 8. This is the machine learning model. This is schematic of support vector regression model. Their input layer is process parameters and statistical parameters. Process parameters are used during the machining process of the experimental setup, and statistical parameters are found like using those signal processing techniques. Like these A signals are then used like transfer to the like discrete oblate transform, and through this discrete oblate transform, this signals through this discrete oblate transform, these statistical parameters are found, and the output layer is tool and follower says. These are the obviously image of the machining holes of 27 of experiments whatever I have done here. This is the experimental observation. Here, input parameters are considered abrasive greases, slurry concentration, and power rating, and output process parameters are considered tool wear and hollow versus. And these are the statistical parameters like RMS of acoustic emission time domain, RMS of acoustic emission frequency domain, this Cartesius of acoustic emission time domain, and Cartesius of acoustic emission frequency domain. Cartesius means thickness of the signals, and these are found like through the discrete oblate transform. This is like time domain and frequency domain. With this experimental data, like NARHE analysis was performed. Here, this abrasive greases, light tension, and poverty. With the increasing of abrasive greases, the tool wear is decreased. In case of slurry concentration, as the slurry concentration increases, The two-layer initially decreases, then beyond an optimal value, it increases. Similarly, in case of power rating, as power rating increases, the layer initially decreases, then the optimal value increases. This is the minified plot of whole over series. With the increasing of abrasive grid size, the whole over series is increased, and in case of concentration, as slurry concentration increases, the machining whole over series also increases. However, in case of power rating, as power rating increases, the whole over series decreases. Now, coming to the results discussion part, machine learning model. Here, SVM model or SVM in SVM, like sphere model is developed. Two conditions are applied. One is like two conditions applied to observe whether it's signals, if signals are used during how accuracy is differ, like how much accuracy is increased or decreased with the application of signals. To observe that, two models are separately developed. One is like support vector regression model with only process parameters for the prediction of two layer, and another is with signal features. This is considered as only process parameter, and an open source Weka software program is used to develop this model. Here, out of 27 set of data, 22 data sets are utilized to train the network, and 5 data sets are used to test the generated network. For the development of the SVR model to monitor the two layer during the USM process, the range of parameter C is cost function. C is taken to be 1 to 100 in steps of 1 in order to determine the best set of C. Similarly, the range of gamma is considered as 0.01 to 2 in steps of 0.01, and epsilon is considered as 0.01 to 1 steps of 0.01. That is optimized SVR parameters for the model is found as C cost function is 70, gamma kernel function is 0.09, epsilon marginal error is 0.04. So with this model is when only parameters is used, the mean absolute average percentage error is found as 15.11. It means the accuracy is found as 84.89%. While the SVM model with signal features are used, then the how accuracy is there during the two-layer prediction. For this development of the SVM model to monitor the two-layer during the USM process, the range of parameters C is taken to be 1 to 100 steps of 1 in order to determine the best set of C. Similarly, the range of gamma is considered as 0.01 to 2 in steps of 0.01, and epsilon is considered as 0.01 to 1 in steps of 0.01. Here, optimized SVM parameters for the model C 95, gamma 1.2, epsilon 0.04. Here, it's when signal features are added with the process parameters, then it seems that it's like absolute average percentage error is found 3.87%. It means its accuracy is 94.13%. So it is observed that when signal features are used, then the accuracy is increased. Hence, for the whole overseas uh, like with signal features is developed for the for the development as a model, signal features are added. Similarly, for this development of the Azure model, to monitor the whole overseas in the machining, the range of parameter C is taken to be 1 to 100 in steps of 1 in order to determine the best set of C. The range of gamma is considered as 0.01 to 1 steps 0.01, and epsilon is considered as 0.01 to 1 steps of 0.01. Here, optimized SVR hyperparameters for the model is found as Cost function is 65, kernel function 0.7, and marginal error 0.07. Here the absolute percentage error is found as 2.13%, means accuracy is 97.87%. Now coming to the conclusions. Through ANOVA analysis, with the increasing of abrasive greases, the tool wear is decreased. In case of slide concentration, the slide concentration increases, the tool wear initially decreases, then beyond an optimal value, it increases. Similarly, in case of power rating, as power rating increases, the tool wear initially decreases, then beyond an optimal value, it increases. With increasing of abrasive greases, the followers is increased. Similarly, in case of slurry concentration, as slurry concentration increases, the machining hollowverses also increases. However, in case of power rating, as power rating increases, the hollowverses decreases. So, as V analysis, it is found that the model developed for tool wear prediction yields an accuracy of 96.13% compared to the model developed with only process printers, which delivers an accuracy of 84.89%. For the followverses, the model versus prediction yields an accuracy of 97.87%. Feature scopes and limitations. Here, like different types of prospectors can be considered for different response meters in further research. So, acoustic emission and current sensors are used in the present emission. The other sensors, such as meter, a voice sensor, uh, can be considered for further research. So, accidental emission of the present numerical work can be considered for the further research. So, in limitations,
Hello.
like the numerical.
Manish sir. Hello.
Yes, sir. Yes, sir.
Just 1 minute. You can turn on your video and you can speak somewhat loudly
Yes.
actually. Voice is getting very low. So speak loudly and you can turn the video as well.
Okay, that video. Okay, sure.
You can turn on the video as well. Yes. Sir, your video, sir, actually.
Okay, it means I have to increase my voice sound.
Okay. Please
Sorry.
continue. Please continue.
Actually,
continue,
I
sir.
am asking that means whether that actually not sorry. Actually, like I have to increase my sound or I have to like show that video.
Hi. Actually, you have to increase the volume first, and you can turn on the webcam as well.
Yeah.
Your webcam actually, so that the participant can see you as well during the session.
Okay. After completing, then I'm coming back.
Okay.
Limitations. The numerical investigation for the mechanism of material removal in the ultrasonic machining process is complicated, and I'd like to say with this work, these publications are like we have done with this these publications. One publication like engineering failure analysis. This is SAQ1 journal. Another is International Journal of Computer Integrated Manufacturing, SAQ1 journal. Another is Machining Science Technology, SAQ2. These references I have gone through. Thank you for your attention. Any queries, please?
Hello.
Hello.
Sir, thank you for your presentation.
Yes, sir. Shall I play this video again? Or
Yes, you
what you
can
ask?
play. Yeah.
Okay.
So I request all the participants, yes, to see the video, and if you have any queries regarding this, you can have the discussion with this.
Yeah, Dr. Mehdi. Hello?
Sure.
Hello?
Yes, please.
Dr. Mehdi, can you able to listen my voice?
Yes, please. Yes, please. Yeah.
Yeah, you see, it's a very nice presentation, and I am also related to condition monitoring area research only. My name is Anil Kumar. May I know what type of
Yes.
wavelet transform you have used? Whether you
I
have used
have used
DB
that
or
I used Davos's 10 mother wavelet function. DV10.
DB10. Okay,
DV10
okay.
mother wavelet function I have used.
Okay, so
Yes,
initial for
DV10.
filtering, have you gone for this thing, what we call that one? I've forgotten that name. So filtering process, you have shown the acoustic
Yeah.
emission sensor reading now.
Mm,
So for
No.
reducing the
Actually,
noise, what type of filter you have used? Hello?
yes. Your
So
question is that i- yes, have you
for
completed
reducing
your
the
question?
noise, what type of filter you have used? That's what I am asking.
Yes, sure. See, during this filter, during this echoing signals,
Yeah.
to remove these noises and unwanted sounds,
Mm,
bandpass filter is used, and this bandpass filter used during this program, like in program already like added,
yeah.
like before going to yes,
Mm.
this filter is used as bandpass filter.
Band pass filter. Okay.
Yes.
Okay.
Thank you.
So generally, you have shown the DOE with full factorial design, no?
Yes, full factorial design.
So have you tried with anything, this thing, whether we have to go for always full factorial design or we can go for fractional factorial design also, like Cohen BK approach like that.
Actually, yeah, full factorial design I have gone through because of it.
Because you told that initially there are no studies of this thing.
Yes, I say full factorial design used because of like numbers of like more like maximum numbers of like your and correlations between the like input parameters like can be done, like more numbers of experiment can be done like if you go through the factorial
Mm.
method. But like if you go like other method, then the uh, this number of input parameters are will not like can get this like maximum number correlations.
Okay. Okay, sir. Thank you. Thank you very much for the doubt clearing.
Yes, welcome.
Hello, sir. Dr. Magdi, sir.
Yes, sir.
This is Arun Karthikeyan from CMM University. Yes, sir. Actually, yeah, I am also looking for condition monitoring on my machining application, sir. Actually, my work is completely on machining.
Yes,
So
sir.
both conventional and non-conventional machining, I'm currently using that. So here, I think you have selected that grid size, right, sir? Grid size
Yes, sir.
concentration.
Great, sir. Yes, sir.
So yeah, why you are not considered other parameters, sir? Other we have, I think, different
One,
process parameters, right, sir?
one, great size, right? Yeah. I have considered grid size, right?
Yes, sir. Yes, sir.
Okay.
Obviously, actually, it is already
See,
proven
here
result, sir.
abrasive particles,
Al-
abrasive
Already,
particles.
already it is a proven
Sorry,
result,
not
sir. Because
understand. Hello.
no, am I? Hello, sir.
Sir, can you
Sir,
tell me again? I'm not understanding.
sir, abrasive grid size. If grid size is increasing, obviously the whole diameter, the things will be increased, right, sir? Surface roughness is going to increase if grid size is increasing.
Yes, sir. Yes, sir. Yes.
So
Okay.
I think other than this, more significant parameters are there.
Yes, yes. More. Yeah, significant other parameters are can also be considered. Like in my study means I colored this, like you said, or like considered poverty. Like there, I already mentioned here, like several input parameters or output parameters list. Like here, uh, many input parameters or output parameters are there. So, like I considered these three, and I found that maybe like these three parameters are more influence
Okay.
towards the finding these output parameters. Or else
Oh,
means like we can go through all the input parameters noise.
actually, I'm also planning to install this tool condition monitoring for EDA machining, sir. Wire EDA machine, because the machine was
Okay,
available
sir.
in our university. So I'm planning to utilize this setup in our college. So please give me a tip for various parameters going to affect the performance, right, sir? So how we can effectively uh, get the response from the system, sir, if because already you have implemented, right? So
Yes, sir. Yes,
if you
yes.
are sharing some tips,
Like
it
first
will be
of all,
useful to.
which uh, uh,
Yes, sir.
sir, first of all, I want to know means which sensors you are going to use.
No, yes, sir. I'm completely new to this area, sir. Tool condition monitoring, actually.
Okay,
So
okay.
here
Here
we have a
I can say something here. Oh, um, see, you can see here. You can see here. This is like a sensor. A sensor. I keep like I like maintain some distance. I maintain some distance from this machining like a part. Like this is
the
a tool and workpiece, and here is the machining is open, and I keep in some distance that a sensor because uh, first of all not to damage, maybe like this abrasive particles can contact this sensor, then it may damage. And another is to remove some unwanted noises. If I keep here, then like some unwanted noises also can be detected by the sensor. So first of all, I want to know is if you're going to do work like similar kind of work, then I have to know means which sensors or how what kind of sensor means you want to do.
Okay, sir. I think in your case, have you it's vibration sensing sensor, sir, or vibration, or means temperature, or it observes some other thing? What it senses actually?
This is or to like observe like acquire this sound, to acquire
Sir,
this sound like this
sound.
during
Okay.
this machining process sound is generated, and this
Okay.
sound is acquired by this sound is like detected by this sensor.
Okay. So in my case, I think spark will be the spark will. I think it's relevant to temperature, sir. If I place temperature sensor based signals condition
Yes,
monitoring, is it possible to implement, or is there any issues with that? If I do while cutting, definitely the obviously the
yes,
heat is going to be generated, right? If I place the temperature sensor over there, is it a efficient method
yes.
to monitor the tool, or yes?
Yes, yes, yes. You may go through this temperature sensor. I
Okay.
think it will be effective one.
Okay. Okay, sir. Fine. So what are the parameters you have maintained as a constant, sir? Like abrasive flow rate, abrasive flow rate and other things.
No, no. This is
I think you have not included that rates. I means other constant parameters.
yes,
So what
constant
level you have
parameters
maintained?
here. This C is constant, and here feed rate is constant, and here flow rate is constant.
Sir, I'm trying to get that value, sir. Magnitude values.
Similar kind of these parameters are to be constant during this process. Hello.
Yes, sir. Yes, sir. Listening, sir. Yes, sir.
Yes, yes. Actually, that means that frequency. I'm not changing that frequency. That frequency will be constant for all the experiments. And this feed rate is constant. And this flow rate. I'm not changing any flow rate. That flow rate will be same only.
Okay. So have you checked by increasing the or decreasing the frequency ranges, sir? I mean,
Oh, no, 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 no. I
okay.
because of the principle of the machine is that frequency is more than 20 kilohertz. Yeah, I did not
Yes,
check.
sir. After 30 kilohertz also considered as ultrasonic waves. I think, yeah.
Yeah,
30,
actually, through that, yes, yes, your question is good. Actually, through numerical analysis, observed during
okay.
numerical investigation, I have gone through the changing the frequency. I've considered 20,000 hertz and 30,000 hertz, and
Uh-huh.
how this it is changing. But yeah, it seems everything is same only. When I sense 20,000 hertz and 30,000 hertz frequencies, everything is same only. And it is done in numerical analysis only.
Okay, okay, sir. Sir, I think you have not discussed about your tool failure, right, sir? I think
Yeah, yeah.
so. All the experiments you conducted in
Did
a
not get this.
single nozzle, sir, or different nozzle you have used?
No,
I
no,
mean,
no. Tool
different tool.
failure is there,
No,
and
I think you have shown only one
nozzle is
nozzle,
same.
one tool. Yes, sir.
Tool. No, no, no. Nozzle is same, and tool. Yeah, tool was broken.
Okay,
And this is the example, during experiment number 20, and you can. This is during this experimentation, this tool friction, and it is
okay,
this you can imagine that this
oh,
shape of the uh, mm, machine hole is in different.
okay. So,
And this is actually so precise work, ultrasonic machining process. This is something precise, and my workpiece was new, new material, in consumer, right? And it was something challenging. It was challenging.
okay. Sir, suppose I'm going to conduct the same exercise, same experiment. I think you have a model, right, sir? You have already prediction model you have. If I'm conducting the same exercise,
Yes,
can
yes,
we
yes.
be able to predict the true life, sir? Means, okay, after the 10 holes, definitely the tool is going to be failure. Is it possible to get the calculation, sir, with that model?
Yes, yes, yes. Yes, you can do. You can do.
Okay. So have
Only
you
the
valid?
tool is failed, but your program is same. Then you have to yes. This one only I consider. This one I did not go through the different one. Whatever I have found the experimentation, that only means I have incorporated.
Okay, okay, sir. Then thank you so much, sir. I think I have to study more on tool condition monitoring. Thank you, sir. I will take your paper for my reference.
Sure. Yeah.
Thank you, sir.
Thanks for your queries.
Okay.
Hello, sir.
Yes, sir.
I have some doubts, sir.
Yes, sir.
So can you increase your volume, sir, somewhat, so that it can be able to understandable? So there is a small doubt, sir.
Okay,
Actually, when
sir.
you are
Okay, sir.
conducting, when you are implementing the machine learning models, now, sir, SVM models. So for that,
Yes,
how
sir.
many experiments you are conducted, sir?
27 experiments.
For implementation of the SVM models, machine learning models, how many experiments you have conducted, sir, for implementation? So when I'm seeing your slide, 20 experiments you have conducted. So the 20 experiment data only.
Not 20, 27, 27, 20.
To 27
Sorry.
experiments you have conducted, and that only you have used for SVR
Yes.
model, sir.
Right.
So is it enough, sir? The 27 experiment, is it enough for implementation of SVR models? Actually, normally the machine learning means we need a
See,
minimum 100.
more, yes. So if like you do like more numbers of experiment, then it's good. And this is 27 number of experiments is also gives the good result. And even nowadays, less than 27 experiments also like can be like like develop like a model. Like even you don't do like no number 27 numbers of experiment, like 15 and if like do 15 numbers of experiments, then also you can like develop numerical this machine learning model. 27 numbers
This
is
is suitable for
sufficient.
SVR model only, no, sir? Whereas if we go for other models,
Other model also available, like ANN or like CNN, KNN, RNN, whatever you want. Like if you do 20 number or like 27 numbers experiment, then these are also applicable.
ANN and CNN also, RNN also, we can use it 27 model, sir.
Yes. Now I'm going to plan like some other. Actually, I'm like some like extending my research work to the 3D printing. So with that means now I'm going to like again 27 numbers of experiment, and there I'll add like deep learning. In that ANN, CNN, RNN, KNN, I'll apply those machine learning models.
Okay, sir. Thank you, sir.
This is applicable. No issue.
Hello, sir.
Can you able to help me, sir? I have one undergrad experiment, opposite water jet measuring. I have 27 data, but I don't know how to implement it. There's some doubt is there.
Sure, okay. I can contact with you. No issue.
Yeah, Mehtab, actually, in continuation to the previous discussion, what the previous view, I mean, like faculty have commented. Basically, this 27 data set training and testing is not that easy, as far as my experience is concerned. But we mechanical engineers use this tool
Yes.
as a weapon or kind of a thing to target publications in scientific community. Usually what we do, we synthesize the data using this experimental data, and we generate more data by which we train the model using the synthesized data. And using anyway, we use different other techniques to fine tune the model so that.
Sir, maybe you're not having a good network connection.
Pardon, sir?
Your voice maybe.
Is my voice audible?
Hello. No,
am I audible?
I now it is audible. Yes. Now it is audible. Yeah.
Yeah. Is my voice clear now?
Yes, now it's clear. Please continue.
What I want to point out here is like I used these ML models to publish papers where I collaborated with some of my colleagues who will do experimental stuff. kind of heat transfer applications and tool wearing applications. And what I observed is like they also give me the data kind of 18 experimental data set, 27 experimental data set. Why they use this? Because they want to use statistical tools kind of ANOVA or kind of Ben Hop box model. So those kind of tools are fit for 18 data set, 27 data set kind of stuff, 36 data set, 45. So they give very small data sets and they ask me to train this and use ML model to predict the experimental data. But when I gone through it using random forest or SPR or MLP or decision tree regression models, what I observed is like it will give you a result, but when you again train it, it will give you enormous result. Like the results will not match the previous model. What I observed is like this data set might not be like accurate for predicting the model. So, but keeping the fact, but usually the papers will get published, even if small data set also use it to train and test and validate and predict the scores, metric scores. What we usually do is like we synthesize this data, experimental data, what we have, we synthesize it and we generate more data and we train that data. Before training, we fine tune the hyperparameters of ML model so that the ML model will be close to robust. And after that, the synthesized data, we use it as a weapon to test the actual data. So in this way, some or other way, the model will be more efficient than like taking some data, 80% of the data, experimental data to test and 20% to train. This is my experience, but it's very good that your model has predicted even for training 27 data set, sorry, 80% of the 27 data set as a training and for testing 20% of the data set. So my question is like how the reviewers will take it as this, because usually we come up with the problem with the reviewers. Like they used to target, like they used to criticize our like how you can do with 27 data set. So I want to know from your experience, like how you tackle these kind of reviewers questions when they pose the questions like how can you model with 27 data set?
Okay, now coming to a question. See, I published this paper like machine learning approach for prediction of whole overseas using acoustic emission signal features in ultrasound machine in International Journal of Computer Integrated Manufacturing. This is Q1 journal. And other is I have like presented today two output parameters. One is whole overseas, one is two layer. So this is two layer. This machine learning model, this for two layer. This is for whole overseas published in journal and two layer published in this journal, Machining Science and Technology. This is Q1 and Q2. The are like good journals, you know. So during this review process, so I did not find like that question. That means you have done only 27 experiments, and here like within 27 experiments, like few you consider as testing or like this. So like this means how it is possible. I did not get such kind of question from any reviewers.
Basically, you have one more.
I think you understand.
Yeah, understood. I think you have one more work in your paper, like kind of in the second paper, you have acoustic emissions signal features techniques also. So that is one added advantage to your work. And in the third paper also, you have same application in addition to machine learning. So the reviewer might not be expertise in both the fields. Yeah. Usually I come up with these questions. That's why I asked you, maybe you might be having some experience on this.
Yeah. Might be asked by the reviewer. But, fortunately, I did not find questions like this.
Usually in 2020,
It is possible.
for my first paper on machine learning
One
model,
is published in.
I got this question. So after that, from the reviewers itself, I came to know that I have to use the synthesized data. Before that, I have to fine tune the parameters. All these things from the reviewers only. I learned all these things because they criticize our work. I mean, like they criticize for the
Yeah.
better quality of the work. That's good way. So, yeah, thank you. Thank you.
Yeah, it's actually deep, like varies, like it depends on like reviewer to reviewer, their thoughts and expectation. You can't like tell anything about this. Reviewer, can I ask anything?
Any more question from participant?
Hello, sir. This is Arun Karthikeyan, sir. Same here. Sir,
Yes, sir.
common doubt only, sir. Actually, I have developed regression equation, sir, for my same
Yes, sir.
27 exercise, 27 experiment and 3 responses: metal removal rate, surface roughness, and the cutting temperature. So I have developed the regression model. So the residual square is around R square value is around 98 point something, means it is exactly fitted with my model. I think, is it sufficient,
Okay.
sir, to prove my? I mean, is it sufficient to predict the things, right?
Your voice is
Sir, am
your
I?
voice is not actually. I
Yes,
did
sir.
not. Now, please tell me again.
Sir.
Yeah, I did not. I did not like hear your voice. Once again.
Yes, sir. Actually, for same experiment, number of experiments, I have developed the regression model. So in that also the
Yes.
range, the error is very less than 2% only. I mean, on square is around 98
Okay.
point something. I mean, it is good. I mean, experiment data is good fit with the model.
Yes, sir.
I think, is it sufficient, sir, actually to prove the prediction?
Yes, if your accuracy level is high, then it is a sufficient. But somehow, like if some reviewer ask, if you like asking me like regarding the publication or reverse question, then I can say like that. Some reviewers can ask like some other process you can also implement. But, if your like accuracy level is like 98 point something, then it is
Okay.
good. Like in case of here, like this study also, here accuracy level is say 97.87. It means
Okay.
98%. So
Okay.
yes, it's good only.
Okay, sir. And one more doubt, common doubt, sir. Sorry, sir. Actually,
Yes,
I'm
sir.
asking so many
No, no, no.
things.
Yes, sure. You can ask. I'm
Sir,
ready here.
you can ask. We have lots of time.
Oh, yes, sir.
Yes, yes,
Actually,
sir.
here,
Yes, sir.
I think you have fixed 3 levels: low level, low, medium, and high, right, sir? So, if my values are,
Voice is not clear. I did not understand anything.
sir, suppose here we have a abrasive grid size. In your case, abrasive grid size as a one of the process parameter, right, sir? Sir, am
Yes,
I
Yes,
sir.
sir.
audible?
Yes, sir.
Please
Abrasive
continue.
grid says.
You're audible.
Yes, sir.
You're
Low level, medium level, high level. So here we have a definite values. If my value is higher than the higher level, for example, higher level is 20. Suppose I'm going to give the input 25 or 30. Is the model will be given the optimum value, sir? Or my value is less than the lower value? This predicted model will help me to predict the new conditions, sir.
Actually, no, I am not clear. Actually, your voice. Sometimes it breaks. Sometimes it's audible. That's why I'm not able to understand your whole question.
Sir, now it's audible, sir. I think. Please check.
Yes, now it is audible. Yes, now
Yes,
it is
sir.
audible.
Sir, I process parameter we have taken lower value, medium, high, right, sir?
Higher. Yes, sir.
Yes, sir. If I am going, you have developed some model. If I am going to give more than the higher level as a input parameter, means 20 is the high level. For example, 20 is the high level. If I am giving 25 as a input to my model, is the model is valid for that value also, sir? I think.
Okay, understood. Anyway, I
Ah,
understood the question. See, here, like abrasive grids is considered like a minimum, like average and higher, right?
correct, sir.
So it and your question is that if someone take like more than higher value,
Hmm.
we consider this like value like a difference of the range uh, to like for comparable like this, if like I consider 220, 400 and 600,
Okay, sir.
like I was ready to take the 200, could 200 mesh is not available, 200 mesh number or grid size is not available. That
Correct.
is why I have to consider that nearby 200 that was available 220, and 400, 600 is available, so I took 400, 600. So when you take the like range like for comparable, so it will give the like good result. You can compare easily. And if you like to 400 and 800, then your range is not like comparable, then the result will not be accurate, I think so.
Okay, because in I developed a regression model, sir. There I have maintained three
Yes sir.
input parameters X, Y, Z. So,
Yes
here
sir.
I my lower and upper limit are fixed. In this limit only, the model will give 98 point some accuracy. So if
Yes
the
sir.
limit is if the variable is other than this limit means are more or higher than the limit, the accuracy is supposed to be not there. Means it will not show the exact value. So this is the way I have concluded, sir. So I mean, yeah, if the things will be improved if you are using with any machine learning techniques like you are using something as a SVM and
Again, last sentence I don't understand. Maybe network
Ah,
issues.
yes, sir. Actually, here I have a fixed levels, low, medium, high, right? For regression, out of
Yes sir.
27,
Yes sir.
out of 27, okay, it will be give some optimum value if my input values are other than the fixed limit. The regression will not be valid. Like the such a kind of comments I have received from the one of my paper. So this issue can be solved if I using any AML technique.
No, if I'm not wrong, maybe your question is that like if you like not taking the like with ranges, then means whether it is like some other like machine learning techniques can be applicable or not. Yeah.
Yes, sir, correct.
Okay.
Hi, sir. Good
Then
evening.
hello.
Sir,
Please,
Yes, yes.
please go on, sir, if you are in between something. Actually, I was trying to ask something, sir. Hi, can I, sir?
sir, just wait. One question is in process.
Sure, sure.
Just
yes, 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 yes.
sir,
Yeah.
please.
So yeah, you can apply machine learning models. And so,
Okay.
so machine learning model it will not predict which like input parameters you considered, like how like ranges you consider during your experimentation. You can like is consider or you can apply machine learning models in this
Okay.
case also.
Okay,
Sir,
sir.
next,
I have one more query, sir.
sir,
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 here
please,
in conventional machining, we used to
sir,
follow
sir.
TS equation, two life equation, Vt power n. So if it reaches that blank flank here, we stop the machining and the tool will be considered as the failure one. So in this case, how we can identify the tool is failure? I mean, it has any ranges, sir? I mean, how you are when you will stop the machining?
So for that means you have to like use the algorithm like before going to the experimentation. So like during your experimentation means you should apply that algorithm like that means this predictive like failure or predictive maintenance can be like a record this algorithm so that you can know that means this that time that tool is failed and is totally monitored by this algorithm only.
Okay.
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 Next question, sir.
Okay, sir. Thank you.
Hi, sir. Good evening.
Yes.
Good evening.
Yes. Yes, sir.
Sir, I would like to ask one question that in machine learning, we do have, say, neural net, we do have GPR, SVR, random forest. We are having number of machine learning techniques. What happen most of the time, reviewer ask, what is the basis of applying SVR? Or it is just for the sake of publication that you haven't find any paper on SVR. Might be you haven't applied ANN like this. Being a mechanical engineer or being a background that is not very much say of firm foundation in machine learnings, how do we cope up with these kind of questions? Because we are having even SVR, we are having different kernels. How to say justify the application of that particular method? Am I clear, sir? I mean, question is clear or not, sir?
Yeah, maybe your question is that means some or if you're asking that SVR means why you not go through the SVR, you're applying like ANN or like some other processes. Is this your question? If I'm
Sorry,
not
sir.
wrong.
My question is we are having loads of machine
Hello.
learning techniques. Hello, am I audible, sir?
Please, please repeat once. Yeah, last actually I did not hear your voice.
Actually, my question was like, sir, we as a
Yes,
mechanical
please.
background, say we have to do some experimentation, and top of that we have to justify the machine learning approach. And in our literatures, we find many like neural net. We are having SVM, we are having GPR, we are having other methods as well. So how to justify that? Why do you use SVR? Like this kind of question kept on striking us in your question in your paper. Why do you have used this kind of? Even SVR, we do have number of kernels. So how to justify that?
Hello.
Yes, sir.
In expert, I think you might have. Niraj, sir.
Actually, sir, I'm
Hello.
typing in chat box also.
Yeah, am I audible? Yeah.
Sir.
Yeah. So this. See, SBR model is the common machine learning model. So easily, the researchers used SBR model. This is the very common machine learning.
No, sir. My question is like neural net is also very common, ANN. So sometime what happens, we apply say
I
SVR.
didn't understand the question.
Okay, sir. Thank you.
Jagtap, sir.
Not understand, please. Again. Yes, sir.
Jagtap, sir.
Hello.
Yes, sir.
So I hope all the questions
Please.
have been asked by the participants and no one is remaining. So I came to the end of the sessions. So on behalf of Zeal College of Engineering Research Pune and Department of Mechanical Engineering, I extend our sincere gratitude to Dr. Mehdi Mehtab Mirat for delivering such a good session on a topic signal-based data-driven condition monitoring in ultrasonic machining of ICONEL 718. So in these sessions, he has focused on ultrasonic machining processes, condition monitoring, machine learning models, support vector machines, and many things he has covered. So we are truly thankful to you, sir, for sparing your valuable time and sharing your international research experience with us. Finally, I extend my heartfelt thanks to all the participants from various institutes for their active presence, enthusiasm, and interaction, which truly made this session meaningful. We look forward to your participation in upcoming session of this FDP. Once again, thank you all. So I request Dr. Rita Pure sir to continue.
Okay. Gadde sir, good evening. Gadde sir.
Yes, sir.
Yeah, please share your screen.
Yes, sir.
Please share your screen.
Yes, I will do that.